Let's start solving part B in this video. So suppose that the company cannot observe the effort level, but only the total production Q. And we also know that the wage is based on a fixed salary and a bonus based on output. Now calculate that optimal bonus and the fixed wage A. Do the workers put more or less effort, and explain that. Okay, so what's the difference now? In part A, the firm was observing the effort, and that was the most important thing, because they were basically forced not to free ride. They had no option of free riding. That's why they were maximizing the team utility, where they care about the total production of the team and the cost of effort of each worker. What happens now is that the firm does not observe the effort level, meaning that the workers are only going to maximize their individual utilities, taking into account how much money they can make and thinking only about their own cost of effort. So what does the utility function look like right now? So for instance, the utility of the first guy is going to be the same. Sorry, not the same, but the following. The wage, and the wage is A plus B times quantity. So let's substitute that. We will have A plus B times the quantity. And what is the quantity? The quantity is theta times E1 plus E2. So let's write that in a different color. We have over here theta times E1 plus E2, and he has the cost of effort. This guy has a cost of effort minus 1 over 2 over here times theta e to the power of 2. So minus 1 over 2 theta e1 to the power of 2. What we notice is again a relationship between the utility function and the effort level, meaning that we are going to differentiate the utility function with respect to that effort level, make it equal to 0. So we do so. Let's see what we get as a result. A derivative, that's a constant derivative with respect to the effort level, is equal to 0. B times theta times e1 plus e2 is just b times theta minus 1 over 2 theta times e1 to the power of 2. Derivative with respect to e1 is just going to be the constant of 1 over 2 times theta, and e1 squared derivative is 2 times e1. Make that equal to 0. So let's cancel out some stuff over here to see what we get. 2 and 2 go away, meaning that we have as a result b times theta. So we have over here b times theta minus theta times e1 equal to 0, meaning that e1 is going to be the same as e2 since they are symmetric, right? Let's write it like that. e1 is going to be the same as e2, and that's going to be equal to b times theta over theta. So that's b times theta divided by theta. That's the effort level that we found. What we also need to find out, now is the fixed salary, right? Because how is this process going? The effort level depends on the utility of the worker. The worker maximizes his effort level because he is not verified by anyone, so he thinks about himself first. This is first, right? Effort level. Then the company must offer a salary, a fixed salary A, to attract the worker to not go to the other company, meaning we have to take into account the utility at this company versus the alternative utility. And finally, when we think about the bonus is given by the company would give a bonus that maximizes his profit. So it's all these three steps that depend on the worker first and then on the company. So let's do now the fixed salary A to find out, and then in the next video we'll find out the optimal bonus level. So to find out over here, let's put it like that, the salary A, right, the fixed part, we have to compare the utility in this company with the alternative utility. So the utility over here must be equal to the alternative utility. What is the utility in this company? Well, we have the function over here. Let's just copy and paste it over here below to know what to substitute in. This is going to be the utility like that, and we found out the effort level as well. So let me just zoom out to get more space. So over here we go below. Hold on, like that. Now this is going to be the utility. Let's substitute what we can and see how it will look like. We will have the following: A plus B times theta times the effort levels, and the effort levels are the same, meaning we will have B times theta divided by theta multiplied with 2, right? That's the effort of the first guy, the effort of the second guy, minus the cost of effort. So minus 1 over 2, we will have minus 1 over 2 times, we are here at the second term, times theta times effort to the power of 2. The effort level is b times theta over theta, so everything to the power of 2 is going to be b squared theta squared over theta squared. That's the utility function. Make it equal to the alternative utility, so that's going to be equal to v. We have it like that. Now theta with the theta goes away. What do we have as a result? We would have a plus b times theta multiplied with b times theta from here. That's b squared theta squared over theta, and we still have the 2, so multiplied with 2 minus 1 over 2. Let me change colors. Minus 1 over 2 minus 1 over 2, b square theta square over theta. That's what we're left with, b square theta square over theta. What do we notice? We have a subtraction of the same term. That's b square theta square over theta times 2 minus a half of the same term, meaning we'll subtract the coefficients. 2 minus a half is just 1.5. And this is all equal to v. Let me just not forget to write that, because that's what we're solving for. That's all equal to v, meaning that we will have the following. We will have a plus 2 minus a half, that's 1.5, that's 2 minus 0.5, multiplied with this entire term, so that's b squared theta squared divided by theta equals to v, so that's equal to v. Now let's take this term to the other side. Let me show it. Let's take this one to the other side to keep only a. That's what we're interested in. We're interested in the optimal fixed salary. That's going to be v minus 1.5 over here, multiplied with b square theta squared divided by theta. Now, a brief interpretation here, because this really matters to understand what's happening. So this matters. Notice the relationship between the bonus and theta on a. So what's the bonus, right? The bonus, if the bonus goes up, the effect on the fixed salary is negative, because that's going to be a term multiplied with minus 1.5. This is a negative effect. So a is going to decrease. Why would a decrease? Well, the intuition is simple. More bonus, less fixed salary required, because the money compensated via the bonus covers the fixed salary. That's why the worker can accept less money. That's the intuition. But let's understand the intuition of this one now, the theta. If theta goes up, a would go down because of the same logic. We have a negative coefficient next to theta. What is theta? Theta is the team effect, right? Theta is the team effect. Now, why would we need less compensation if we have a higher team effect? Well, because remember, the team effect would increase total production. If we have a higher synergy, basically if we have good cooperation with our coworker, we can produce more overall. If we can produce more overall, the company can make more money and we can get more income as a result. So that basically means more money, right? Higher salary for the worker overall, and also means more utility. So because we can make more money due to the fact that we are selling more, we are having a benefit, because the amount that we're selling more is compensated by the bonus. We're getting a bonus for that production. And since we're getting a bonus for that production, then we require less fixed salary, because the effect of the bonus compensates that. I hope you can see this trade-off. Hope this all makes sense. In the next video, we'll see what the optimal bonus is.